G'day guys, you're back with MiracleMAX. Today we've got something a little bit different. It's still electronic. We have a fish tank light bank, an LED style. As you probably noticed, I'm not in the lab today, but I'm out in the workshop. Reason being is because Mrs. Miracle caught me working on this thing on the kitchen table, so I'm out of here. It's too big to work on in the lab anyway. So what's wrong with this thing? Check it out. So let's get into it. This particular light bank has two separate power supplies, one for the blue LED and one for the white LED. In this particular case they run in parallel to one another, but the LEDs themselves are in series. Now notice the blue ones on the top bank here are working, but the white ones are not working at all. So do we need to check the power supplies? Well no, of course we don't, because at least the white ones are working, so we know that the power supply for the white ones are okay and the power supply for the blue ones are okay. But what we do need to check is make sure that there is a power supply coming up to the top bank here, which is the white lights. So we'll check that next. As I mentioned, this light bank is supplied by two separate power supplies and two individual light switches, one for the blue, one for the white. And for those playing at home, it's 240 volts coming in here in Australia, and the output is 55 volts DC, 1.5 amps. And the other one here is once again 240 volts here in Australia. Up the top it says it's between 18 to 42 volts with half an amp is our DC output. So first of all we need to establish that we have power coming in through these sockets here and going off to each bank. Both banks will need both power supplies to them, so I should have power across these two and across these two as well, plus those and those as well. Let's have a look and see what the voltages are. So this power supply here comes in through here, goes off to this connector here and down to here. We'll just go in, I believe that's positive there, that one should be negative I believe. And we have 27.49 volts, excellent. And this power supply over here comes down to here and also down to here, so we can try those two and see what they measure. And we've got 54 volts, don't worry about the negative. I've got the probes connected backwards, and of course up that end it has wires that connect the whole circuit to complete the circuit. So once again I'm not concerned about the voltage coming in here or here, and I know that both banks are being supplied. So why is it that we have blue lights working everywhere and white lights only working on one light bank? The reason being is because these two light banks are in parallel to one another, but the individual LEDs are in series. But what does that actually mean? Let's have a look on the whiteboard. First things first, what is an LED? Well, LED stands for L, E, D, and what that stands for is light. Let's see if I can get that in there. Emitting, diode. Excuse the writing, I didn't have a chance to draw it to scale or to colour it in. So as you can see, LED, light emitting diode. Light, well we know what light is. Emitting, that means it puts something out. So light is being put out by what? A diode. What's a diode? A diode is like a one-way valve. Let me show you. A diode is basically a one-way valve. It has a little silver band on it indicating which way you should put it in. You have a cathode and an anode, and that tells you which direction to hook it in. It only allows current to pass in one direction. So it may pass this way, but it won't allow it to pass this direction. Let me show you. So if I hook it up this way, we see that nothing happens. All I'm going to do now is turn my diode around and notice what happens. Current passes and the light comes on. That is a diode. So a light emitting diode is nothing more than a diode, but it has light passing through it. So in our case we have two light banks, don't we? One up the top here and one down the bottom here. Out of those are two connections. but also they're in parallel, as I mentioned. So this one here will go off to this light bank along here, and then this one will go along here, but also we have another, and that'll go there and there of course, but also this one here goes down to another connector over here, and that will create an earth over here. So there's 4 in total, and exactly the same. This fella up here will go up there, so there'll be 4 connectors on each bank. It's getting pretty messy here, Max, but you get the drift, don't you? So in other words, we've got both power supplies at here and here. Keep in mind that we have a positive here and a negative on the other side, but as I said, they are both in parallel to one another. The problem being now is that we have our LEDs are not in parallel, they're in series. So let's just take an example. We'll leave that there, but these little light banks come off, of course, with a little LED. And series is like this. So in other words, if I've got a power coming in, I have my LED, then there's a power going out, and there's another LED, and there's a power going out, another LED, you get the drift. See, the thing is with series, if I happen to blank out one of them, like that, you can see there's a break in the connection. No current will pass. Not only will it affect this one here, but it'll affect all the others along that circuit. So therefore that's why all the white ones are out. One of those LEDs, at least one, is out in that particular circuit. So up here, the white ones, one of those LEDs is out. How do we test them? It's actually not that hard. Let's head back out into the workshop and have a look. As you can see, it's the top bank that all the white lights are out. So if we cruise along, you can see the bottom bank has all the lights on, but unfortunately it's the top bank that is missing all those white LEDs. So let's check them out and see what the problem is. Unfortunately, it's a bit of a long-winded process. What do I need to do? Well, remember all of these were in series, the white ones, so along here I'll have to remove every single one that is meant to be a white LED. These have little reflectors on them, or lenses, and you can, after a little bit, I've had these pulled off before, you just pop them off and that exposes the LED in behind it. How do I test that LED? Well, there's several ways you can do it. For starters, I can use my multimeter with the diode function attached to it. So I just bring it round to there, and you can see the little diode symbol, that one there, and by pressing this button here we can see it coming up on the display. So to test the LED, if they're in circuit, you can go like this, and you can see the little LED has come on. We're supplying around about 3 volts to it, and if we go backwards we can see that no light comes on. Therefore that shows that that LED is working. Current will only pass in one direction. Another way of testing your diode is by doing exactly the same sort of test, except we pass it this direction and we'll see a measurement going across our meter, and if we turn our leads around the other way we should have 0. So as mentioned, current will only pass in one direction. The forward voltage will depend on the type of diode that it is, but in this case, generally speaking, you'll find about 0.5 of a volt forward voltage. Another method you could use is by using a power supply that you make up yourself. So roughly this is going to be around about 3 volts, which should be enough to light our LED. It's just 2 1.5s chucked in series, and exactly the same principle. If we put it across our LED, it should light only in one direction. Let's try that one. Oh, and there we go. Look how bright that is, hey? Alright, so what I'm going to do is continue along the circuit here and pull off every single one that is meant to be a white LED, and then I can test them individually with this power supply and find the one that's faulty. In this particular case, it's only one LED that's out. Let's have a look. So we've got one there, and nothing here. And if I go further along, I'm still getting LEDs to work. I don't know if you can see that. You're a bit out of frame, I guess, but you might be able to see the lights themselves. There we go. Okay, so it's just this single one that's playing up. I think it was this one, wasn't it? Yes. Let's have a close look at it. Sometimes you might see them when they're actually burnt out, but in this particular case it doesn't look too bad. Is there any way that I can try and prove that this is the only LED that is faulty? Well, it's not that hard. Firstly, we need to establish what sort of voltage we have across a working LED, a white LED. Now you probably can't see this, I'll show you the multimeter shortly, but if we just go across, I've pulled the lens off this particular one, don't know if you can see it, but there's my lens, there we go, out of the light, and I've just pulled the cover off on this working one. So let's have a look at the voltage right across there, and it is reading, we're looking at about 3.38 volts. A little while ago I bought a packet of cheap El Cheapo nasty LEDs. Don't know what they're like, it's not really the point at the moment, but as you can see here, the white ones should cope with around about 3 to 3.2 volts. Now I'm going to give it a burl and see what happens. All I'm going to do is place this over where our blown LED is. What should happen? Well, it's in series. They all should light as soon as I've put on this single LED. So let's give it a try. I appreciate it might be a little bit difficult to see with all the lights in your eyes, but just notice when I put this little LED, that fella there, right across the blown LED that we have. I've just got to remember which one it is. I think it's this one. So if I put the LED in the correct orientation, in other words facing the right direction, we should get the entire bank to come back, and hey presto, we do. One LED. Imagine if someone said, oh, okay, it's broken, let's throw it away, all for the sake of one little LED. So hopefully I can get this sorted for the young guy that owns it, and get it all back together for him at a reasonable cost, including my repairs. So I finally got the LEDs through the post. Took quite a while, to be quite honest. I was surprised that it took so long, but hey, they're here, that's the important thing. So what do we need to do? Let's have a look. As you can see, I've got the old LED off here, and underneath is a little pad. It's a heat sink, to be quite honest. So when we put our new LED in place, we'll need to use some thermal compound. That's this stuff here. It's sort of the white greasy stuff that goes underneath things so that it helps with heat transfer. So it's a thermal compound. We'll stick that back on the LED before we solder it on. One thing of course we need to keep in mind is the polarity of the LED itself. It'll only go one way, it'll only work one way, so we need to check that first. As I mentioned, you want to make sure you get the correct polarity. You don't want to look like a goose and put the thing on backwards and then it doesn't work. So all you've got to do is, as we did before, so we've got negative on this side and positive on that side. Let's have a look. Not working. Okay, so we need to flip it around and put that there and there. Oh, hello, there we go. So the positive is on that side there, or that's how we're hooking it up anyway. And according to our little light here, let's have a look. Flip him around. And nodder. Come on, fella, do your job. There we go. So it needs to go that direction. So I'm actually going to use ye old Sharpie just to make sure that I've got it the right direction. Like I said, don't want to look like an absolute goose. Put it on the wrong way round. So I'm just going to put a little tiny dot there. Come on, fella. Dot. And here we'll put a dot on that side. So I should be right. All I've got to do, chuck on a bit of the old flux. Not the flux capacitor, just a bit of the old flux. Put on some fresh solder, and then just solder it into place. Fingers crossed everything will be honky-dory. So let's just chuck a touch more solder on there. There we go, and touch more solder this side. Oops, get some heat in there, bloke. Better not forget that thermal compound, hey. Just a smidge of the goo. Chuck it on the back. You can see the metal section there that goes against the heat sink on the back there. Just a tiny bit of the goo. Nice. Drum roll please. The important part is, does that bank, because they're in series, does the entire bank work? Only one way to tell. Hey, let's turn on the lights. Firstly, we'll put on the blues. Do the blues work top and bottom? Yay, they do. How about the... Oh, seriously, dude, awesome. It's a MiracleMAX. Man, these lights are bright. Could you imagine the poor old fish below? Chuck in some sliced potato. Before you know it, you got cooked fish and chips, mate. Cooked to perfection. Anyway, the light works. That's the important thing. Time to put it back together. Okay, the hard work is over. Now all we've got to do is reassemble it. We've just got to chuck on these little lenses on top of each one. Now these are sort of glued in place by a type of silicone. Couldn't find exactly what was needed, but hopefully this should do it. It's basically a clear RTV silicone, but the important thing here, it says it's non-corrosive. You don't want anything that's going to cause corrosion on our terminals or wires or anything like that, and damage the plastic and eat through the circuit track. So hopefully I'll just whack on a little bit of ye old silicone and pop these back into place, little lenses. Hey presto, job's done, back to the customer. And of course, before you totally complete the repair, you always want to double check your work. So we'll just turn on those lights again, make sure that we're happy with everything. There go our blue lights, and hey presto, white lights. Look at them, awesome. Now I can finish the end caps and then give it back to the customer. There we go, another job done and dusted. It's out of here. Who would have thought that a simple little LED could have made all those lights go out? I hope you've learnt something about parallel and series circuits. That was the only thing stopping this particular light bank from working, a single LED. Guys, I hope you enjoyed the video, and if you haven't already, please subscribe to the channel, give it a like, feel free to comment down below. Don't forget about that notification bell, give it a big dong, and that way you won't miss any videos at all. So until next time, guys, we shall catch you later. MiracleMAX signing off.